Hi everyone, welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about optical sources which are used for optical fiber communication. So let's start this lecture with the types of light sources available. So first one is LED, which is light emitting diode, and ILD, injection laser diode. So these two are the main optical sources for used in optical fiber communication. So first of all, light emitting diode converts electrical signal into optical signal, which is in which light is used as the communication medium for optical fiber communication. So and also laser can be used as same purpose. So let's go into light emitting diodes in detail. So basic LED operation, uh, normally a diode consists of p-type semiconductor and n-type semiconductor. So like the same way LED also contains p-type and n-type semiconductor, but difference is that here the materials are direct band gap materials. So compared to PN junction diode, so in PN junction diode, p-type and n-type are silicon and germanium. So in light emitting diodes, we use direct band gap material such as gallium arsenide, indium phosphide, like that. So you can see in this picture that we have two terminals, anode and cathode, and the symbol of LED differs from PN junction diode. Here we have an arrow mark in the symbol, and also we use normally uh, gallium arsenide material for p-type and n-type semiconductor. So here we use recombination principle. So basic LED operation, we forward bias the material, and when forward biasing is given, the electron holes recombine in the active region, that is PN junction, so from which layer the light is emitted. And what are the different structures available in LED? So it is based on the optical output from the LED. It is classified based on the surface or construction of the LED. For example, we can have the flat surface, that is known as planar LED, and next is the dome LED. It is like a curved surface, and also surface emitter LED, which is similar to planar, and edge emitter LEDs. So the output is taken at the edge of the chip. So these are the different structures. So based on the application, we can choose any one from this structure, and the LED should have some important properties like high radiance, light intensity, and fast response time, and high quantum efficiency. So let's look into this in detail. So here we have a PN junction which acts as an active or recombination region. So when it is forward biased only, the electrons and holes recombine. And next, working of LED. So here first one is the planar LED, in which PN junction and the surface is parallel to the junction. So here the output is taken from the flat surface. So it is a planar or surface emitter LED. And next we can see edge emitting LED. So generally edge emitting LED are used for fiber optic communication. And next is the dome LED. So dome LED is a curved shaped, so in which we use this for optical fiber communication. And light is emitted at carrier recombination process. So in this picture we can see a transparent cover in which there are two junction, two terminals, and also an active region from which light is emitted. So this cover is transparent plastic case. So here in which light sources is emitted, it is passed through the surface of the dome LED. And based on the material used in the LED, this light color may vary. For example, light color depends on the wavelength. Here the different types of junctions, homo junction, where p-type and n-type are same material. So in this diagram you can see gallium arsenide for both the P and N type. The next type is the heterojunction LEDs. So these have different materials for P type and N type junction. So these are the assessment questions. Thank you for listening this lecture.